Hello dear friends, welcome to a lecture on complex analysis. In this lecture we shall study mappings by the exponential function or the transformation w is equal to e power z. In our earlier lecture we have studied how the transformation w is equal to z square maps a region from z plane to w plane, and we have seen its Cartesian form and polar form also. In this lecture we shall consider this exponential function mapping or transformation by the exponential function w is equal to e power z. We shall consider three examples. The first of it we shall have as example 1. Here we will see how the lines, vertical line and horizontal line in z plane gets transformed in w plane. Now we have the transformation first, w is equal to e power z. W is e power z, and we know z is x plus iy. So therefore it becomes e power x plus iy, or that can be written as e power x into e power I into y. And thus we can write this w in polar form as rho into e power I phi, and see where the value of rho is e power x and phi is y, where rho is e power x and phi is y, and thus a point x comma y, that is z, is transformed in w plane in polar form, whose polar coordinates are e power x and phi. So therefore a point z is equal to xy is transformed transformed, or its image is to a point in z plane in w plane whose polar coordinates are this rho and phi, that is rho is equal to e power x and phi is y. And now we shall consider a point z for vertical line, that is x is equal to c1. We shall consider for a vertical line a point z, or the equation of vertical line we may consider as x is equal to c1. A point z, on it z is equal to c1 comma y. Now see, its x coordinate is c1, y coordinate varies, has image in z plane, image in w plane as the point c1y, x is c1, so its image is e power c1 as the point e power c1, and y is phi, and this is the same y as the point in polar form. And similarly we shall show this in a diagram considering z plane and w plane separately. See, this is z plane, and this we shall have w plane, and x is equal to c1 is this line. This point is c1, and y varies from minus infinity to plus infinity. and therefore its polar coordinates in this point W plane. This is Z plane and this is W plane. Axes are U and V. So the point is C1y, its polar coordinates in W plane will be e power C1. So if this is C1, then e power C1 may be this. Suppose we shall assume this is e power C1, but you see y is changing, and as the point moves along the line, y changes, and y will take value 0 to 2 pi. Then this will trace a circle. So y is 0, this is the ray or the image e power C1 0. If y is say pi by 2, then the image will be e power C1 pi by 2, means this on v axis. And so if y is pi, then this will be the image, and y is 3 pi by 2, the image will be like this, and therefore the point moves along the circle. And we shall draw this circle as, or we will show this by dark line. This is the image of the line x is equal to C1. E power C1, and yes, this is x is equal to C1. Any point on this will have coordinates C1y, and that will be mapped like this. On this is C1. If you consider this as phi or y, then it will be here. Y is pi by 2, the point will be here. Y is pi, then it is this point, and so on. So thus the image of the line x is equal to C1 is circle with radius, with center 0 and radius e power C1. Therefore image of the line x is equal to C1 in Z plane is the circle in W plane with center at origin, at the origin, and radius e power C1. Now we shall consider a horizontal line. This we have considered vertical line, and its image we have seen it is a circle. Now take horizontal line, that is y is equal to C2. A point on a point C, we will consider the point as Z again is equal to, and that horizontal line, its equation is y is equal to C2, and x varies, x comma C2. A point y Z x comma C2 on the horizontal line. Line that is y is equal to C2 has polar coordinates, Now what will be polar coordinates of this point according to this? Rho is e power x, and that is e power x, and this pi is y, that is C2 on W plane. So now we shall see. Suppose this is the line, horizontal line whose y coordinate is fixed, that is C2, and we shall show that line like this. This is y is equal to C2, and it is mapped on this coordinates e power x comma C2. As x is 0, it will be e, and when x will take values from minus infinity to plus infinity, there is no limit for x, but y is fixed, and therefore x will range from minus infinity to plus infinity, and y remains C2. So y is C2 means the phi is equal to C2, and the angle is C2. Angle remains fixed. So here phi is for this point, phi is equal to y is equal to C2, and thus the angle is C2, and that we shall show by this dotted line. This angle is C2, phi is equal to C2, and thus every point on this line y is equal to C2, which is shown by a dotted line, is mapped on this line phi is equal to C2. It is infinite line, and this line is also infinite, and therefore this mapping is 1 to 1 onto. So therefore the image of the line or that means the line y is equal to C2 is 1 to 1, or the line y is equal to C2 is mapped or transformed 1 to 1 and onto manner on the ray phi is equal to C2, starting from origin. So thus every point on this line is mapped on this ray, which is starting with from the origin, and thus we have seen that the transformation W is equal to e power z transforms a vertical line x is equal to C1 into this circle, and this mapping is not 1 to 1, because if y varies from 0 to pi 2 pi, up to that it will remain 1 to 1, but after that the values will repeat, or this rotation will repeat, and thus but this vertical line is mapped on the circle, and this horizontal line is mapped on this ray, which is 1 1 and on. Now we shall consider the second example, how a rectangle is transformed or mapped onto W plane. See, we shall show that the rectangle A less than or equal to x less than or equal to b, C is less than or equal to y is less than or equal to d in z plane is mapped on to the region that is e power a is less than or equal to e power x, is taking exponential transformation, and that is less than or equal to e power b, and this region that will be e power c less than or equal to e power y is less than or equal to e power d, and here phi will take values x y values, that is from c to d, and where see this will not be the y value, because for the transformation only x gets transformed, rho is equal to e power x and phi is equal to y, So therefore the value of y will be the phi will be between C and D, that is C is less than or equal to phi is less than or equal to D. So that will be the correct expression for the region in W plane. This we shall show, and for this purpose we shall draw figure. I shall draw figure here. This is Z plane, and you see the rectangle we shall consider is ABCD, and for that, suppose this is the rectangle, and you see this point we shall name the rectangle as ABCD, and see the coordinates of point this line AD has x coordinate A, and for B we shall consider x coordinate as B, and similarly this y coordinate of A is C, and y coordinate of this point D is D, small d, and that means x lies between. See, this is the rectangle ABCD, how the rectangle ABCD is described. X is between A and B, and y is between C and D, and this rectangle is transformed in W plane. How it is transformed in W plane, that we shall show. See, this is W plane. Now this point whose coordinate is A comma C will be transformed to point e power A, and C is phi is C. So that means we shall suppose e power A is this point here, and e power B is greater than A, so it will be like this, and thus it will have a arc region. Phi is C and D, so this will be phi is C, and phi is D. We will consider like this. This is C, phi is equal to C, and this is phi is equal to D. So the angle is between C and D of the radius vector. And what about these exponential functions? E power A. E power A, we may consider this as e power A, and we may have this as e power B, and therefore this will be the arc e power A, and e power B will be this arc of a radius e power B. And this is the arc e power A. So thus this we shall show as A dash B dash. This is A dash, this is B dash. You see this line segment AB is transformed from this AD, not AB, AD is transformed, whose x coordinate is A, e power A, and it y coordinate C to D, means angle varies from C to D. So this is A dash D dash. The line segment A dash D dash will be transformed or have image on this A dash D dash. And what about this? This is B to C. So this will be B dash C dash. So this segment BC is transferred on this arc B dash C dash, because this point has B x coordinate B, so its radius vector will be e power B, that is here, and that will be traced along the circular arc, and thus this region, the rectangle ABCD is mapped on this part of the arc segment, and that means AD is mapped on A dash D dash, BC is mapped on B dash C dash. And if you consider an intermediate line segment like this, then that will be mapped on this segment in this way. C takes values from angle takes values from C to D, phi takes values from C, this is phi is equal to C up to phi is equal to D. So, or we may show like this, this is the region of the rectangle, and that is mapped on this region. So, rectangular region is mapped like this on a segment between these two arcs. So, in this way we can have the Z transformation from exponential transformation. W is equal to e power z, and in a particular case we shall consider here again as in particular if here see D minus C is less than pi, then this region will be in the circular, that is first quadrant and second quadrant, that we shall consider. In particular, if 0 is less than, or D minus 0 is less than or equal to phi is less than or equal to pi, that means this angle is between 0 to pi. Then what about the region here? Then we have, see, the figure will be like this. This rectangle we will show starting pi is equal to 0, means y is 0, y coordinate is 0, here y is pi, and here y is between C and D, and now here y is between 0 and pi, that we have to see. So this is ABCD, and this will be mapped on W plane. Now for AB, it will be having x coordinate as see, suppose x coordinate of A is A, small a, and this is B, and here this is pi or pi I, and here this phi is 0, y is 0 means phi is 0, and y is pi I means y is pi, and therefore now we will have e power A is the radius of the radius vector, and that we will assume it is here e power A, and the value of phi is between 0 to pi, and therefore this radius vector will trace a circle having radius e power A, and angle varies from 0 to pi, and for this point it will trace a circle with radius e power B and angle varying from 0 to pi, and therefore it will be of this type. So it is e power B, and thus this rectangle will be transformed to this circular ring in first quadrant and second quadrant. This is U axis and this is V axis, this is W plane. This is a particular example of this transformation, and thus we have this rectangle is transformed into this circular ring, or this point is A dash, and this point is B dash. This point is you see D dash, and this point is C dash. So the region is like this. So this is the image of rectangle in Z plane, which is a circular ring in W plane. Now one more we shall consider is infinite strip parallel to x axis as third example. An infinite strip. Zero less than or equal to y is less than or equal to pi. How this is transformed? In Z plane. Consider an infinite strip in Z plane, and here x will vary from minus infinity to plus infinity. And we shall consider this infinite strip, and we shall show this in diagram. See, y is pi, as in this case also, and suppose this is pi I, and this will be the infinite strip. So this is y is equal to pi, and this is y is equal to 0. Now if I show it on the W plane, now see an intermediate line y is equal to ci, that is y is equal to c, will be mapped. How this line will be mapped? We have seen earlier, a horizontal line will be mapped on a ray, that is phi is equal to c, and therefore this line will be mapped on phi is equal to c. And further we will have, this is phi is equal to c. But what about phi is equal to pi? Y is pi means phi is equal to, see here we have pi is between 0 to pi. Phi is equal to 0 is exactly this line, that is u axis. Phi is equal to pi is this line, this ray, not line but ray, and thus these are the boundaries. Phi is equal to 0, phi is equal to c, and y is equal to c is intermediate line. That means this line is mapped on this ray. Phi is equal to pi by 2 will be mapped on this v axis, and thus image of this infinite strip, that is here, will be the entire upper region. V is greater than or equal to 0. That means that every horizontal line will be mapped on this first plane like this, and so on, ray passing starting with origin. So thus these lines will be mapped onto ray, and that the entire infinite strip, its image will be the first and second quadrant, that is v is equal to 0. Thus the image of this infinite strip, 0 less than or equal to y less than or equal to pi, minus infinity is less than x is less than infinity is the upper half plane, that is v greater than or equal to 0 in w plane. In this way we can have some transformations using this transformation w is equal to e power z, which is exponential function. So I hope you can understand this. Thank you for watching the lecture.